Hi, in this video, I wanted to go over a couple of problems involving estimating population proportions. So this is one of your homework problems. It says, use the sample data and confidence level given below to complete parts A through D. So we have a research institute poll, and it's asking respondents whether they acted to annoy bad drivers. So in the poll, there were 2,630 respondents, and this many respondents said that they honked, meaning they acted to annoy a bad driver. And we want to use a 99% confidence level. So the first question is, what is the best point estimate of the population proportion P? The best point estimate for a population proportion is always the sample proportion. And to figure that out, the formula for that is x divided by n. So in this problem, we have 1128 divided by 2630. And it says to round to 3 decimal places. So let's go ahead and work that out. So we have 1128 divided by 2630. All right, so rounded to 3 decimal places, this would be 0.429. So this is the sample proportion. So in the sample, this is the proportion that represents those who honked. The second question says, identify the value of the margin of error, E. So here's the formula for E. This symbol here represents the critical value. So this is the critical value. And we have some common critical values given some common confidence level. So a lot of times the confidence level that we're going to see very often is 90%, 95%, 99%. And the critical values for those confidence level are these. Now, when it comes to the critical z values, meaning if it's a z distribution, then these will never change for these confidence levels. So for a 90% confidence level, the critical z value would always be 1.645 and so on. Okay, so in this case, with the problem that we're dealing with, the confidence level is 99%, so the critical value is 2.575. So we're just going to plug it in. So we're going to have this as 2.575, and then we're going to multiply that by the square root of p hat. So p hat is the sample proportion, and we just figured that out there. So that's 0.429. And then q hat is the opposite proportion of p hat. So in this case, if p hat represents those who honked, q hat would represent those who did not honk in the sample, the proportion of those who did not honk. So that's always equal to 1 minus, because they're opposites or they're complements, it's 1 minus 0.429. Okay, so q hat would be 0.571, and then divided by n. N is 2630. So I'm going to plug this into the calculator, see what I get. So we're going to do 2.575 times second x squared to get the square root. And in the square root, we're going to just input those values times 0.571 and then divided by 2630. Okay, so the margin of error rounded to 4 decimal places is equal to approximately 0.0249. All right, so now that we have our margin of error and our sample proportion, we have enough information to construct a confidence interval. So this form of a confidence interval is an inequality form. There's 3 forms. If you guys refer to the notes, there's 3 forms. This is the inequality form. So this is lower bound less than P, the population proportion, less than the upper bound, or lower limit, upper limit. So lower limit is equal to P hat, which is the sample proportion minus the margin of error, and then the upper limit is p hat plus the margin of error. So in this problem, we have 0.429 minus 0.0249, and then 0.429 plus 0.0249. Okay, so work that out on the calculator. So we're going to get that's the lower limit, and then copy and paste that and just change this to a plus sign, evaluate, and that's the upper limit. So the lower limit is 0.404. Again, we're going to round to 3 decimal places, so that's why we get that. And then the upper limit is 0.454. So if we write this as an inequality, we're on your homework, all you're going to do is just input this into the lower limit and then input this into the upper limit. But if we wanted to write this as a confidence interval in inequality form, it would be 0.404 less than p less than 0.454. All right, so that's it for that problem. Let's look at another problem. So for example, let's look at this problem, which says, use the given data to find the minimum sample size required to estimate a population proportion or percentage. So in this case, if we're ever interested in, say, calculating some kind of population proportion, we have a couple of formulas that would give us the minimum sample size, the minimum number of values we should sample, given the amount of margin of error that we want to stay within, and also given the confidence level that we want as well. So in regards to estimating a population proportion, there are 2 formulas for minimum sample size. The first one here is where we do not have an estimate for, we do have an estimate for p hat, the sample proportion. So this is where p hat, the sample proportion, is known. And the second formula is where we do not have an estimate, so p hat is unknown. So if we look at this problem, it says that p hat and q hat is unknown. So in that case, we're going to use the second formula. All right, so I'm going to rewrite that formula just down here. So n is equal to the critical value, quantity squared, times 0.25, and then divide that by the margin of error squared. All right, so the critical value, let's see, we're looking for this critical value. The confidence level is 90%. That's one of our common confidence levels. So for a confidence level of 90%, critical value is 1.645. All right, so 1.645 squared, and then we're going to multiply that by 0.25, and then we're going to divide by the margin of error, which is given to us there, 0.04 quantity squared, and we're just going to evaluate this. I do want to warn you guys ahead of time that some of the problems on the homework is not going to explicitly say margin of error is equal to a value. Some code word for margin of error may be like within, so it may be like, it may say something like within 4 percentage points, or plus or minus. You know, if they say plus or minus, that's another code word or referring to the margin of error. So I just want to give you guys a heads up on that as well. All right, so let's evaluate this, see what we get. All right, so we have 1.645 squared, so we're going to click this x squared, and then we're going to multiply this by 0.25, and then we're going to divide, right, the fraction bar is divided by 0.04 squared, so we're going to x square it again, evaluate, and our answer is, what we get is 422.816 ... Notice how it says round up to the nearest integer. So very important that you understand that whenever we're calculating sample size, minimum sample size, or in other words, we're calculating n, right? N is the minimum sample size. in this problem, we're always going to round up. So in this case, the answer would be 423. So this is the minimum sample size we would need, the minimum number of values or people or body weights or whatever we're doing to collect so that we would get um, a confidence for a confidence level of 90% and to be within 0.04 margin of error. So one more thing, just I want to emphasize this point. Let's say that we worked this out in the calculator. And let's say instead of getting that, we had something like 422.017 dot dot dot. So what would our answer be? It would be 423. Now you might say, well, it doesn't round to 423 because this is a zero. Again, we always round up when we're dealing or when we're calculating minimum sample size. It is, again, this only applies to minimum sample size. Anytime you're calculating minimum sample size, you round up regardless of what this decimal number is. The only time you don't do anything is if you get an exact whole number for an answer. For example, if you calculated this and you happen to get like 422, then in that case you wouldn't round up. But as long as you get a decimal value, you're always going to round up. For example, if you had 422.0000001, you round up. As long as there's a decimal part to your answer, when you're calculating and using the formula to calculate minimum sample size, you're always going to round up. All right, hopefully that makes sense. Um, as always, shoot me an email if it doesn't.